Hey there. We're always looking up to the sky for these big futuristic solutions. But what if one of the biggest answers to pollution was, well, literally right under our feet? In this explainer, we're going to dig into a really surprising innovation that could change the very foundation of our world.
Just for a second, look around you. The walls, the floor, the ceiling, they all give us one of our most basic needs, shelter. But have you ever stopped to think about the environmental cost of the very materials keeping you safe and sound?
So when we talk about pollution, it's pretty easy to picture car exhaust pipes and big factory smokestacks, right? And yeah, of course, that's a huge part of the story. But the reality is, it's a much wider, more tangled web of causes and effects. And because it's so complex, solving it takes a whole bunch of different approaches. We focus on things like treating our water, preserving green spaces, managing our trash. All of those are absolutely crucial pieces of the puzzle. But what if one of the biggest polluters isn't just about what we throw away, but about the very ground everything is built on?
It all comes back to the ground beneath us. This quote really says it all. Healthy soil is important to maintain a healthy ecosystem. It keeps the life on Earth. It's not just dirt, it is the foundation of pretty much everything.
And that brings us to a pretty surprising villain in our story. A kind of dirty secret that's hidden inside the walls of our homes, our schools, our offices. We're talking about the actual building blocks of our society, bricks and cement. Here's the real dilemma. Our basic, essential need for shelter has, for centuries, come at a really high environmental price. The way we've created durable building materials has always been a story of consumption and pollution.
So, where exactly is the problem? Well, with two of our most common materials, bricks and cement, the issue really boils down to just one thing: heat. Immense energy-guzzling heat.
Get this, 1,000 degrees Celsius. That is the temperature you need to fire a traditional brick. Just try to imagine the sheer amount of fuel it takes to keep furnaces that hot on a global industrial scale. And if you thought that was hot, well, the problem gets even bigger. For the ingredients in cement, the core of concrete, we have to crank the heat all the way up to 1,450 degrees Celsius. That is hotter than flowing lava. Creating temperatures like that takes a staggering, almost unbelievable amount of energy, and burning all that fuel produces enormous amounts of pollution. That's the hidden environmental cost that is literally baked right into our buildings. But what if there was another way, a method to create strong, reliable building materials without the fire, without the furnace? Well, this is where scientists and engineers are completely reinventing the rules of construction. And the answer, it turns out, is beautifully simple. It's been here all along. The solution isn't some complex synthetic polymer. It's the very soil we walk on every single day.
So how in the world does this work? Well, scientists have developed this remarkable four-step process. First, they start with something called subsoil, not the precious topsoil we use for farming. Then, they add some carefully selected chemicals that react with the natural minerals in the clay. This kicks off a chemical reaction, creating an entirely new substance, a super powerful binding agent.
The end result is what they call a glue-like substance. And this isn't magic. It's a fundamental chemical change that transforms simple clay into a super binder, one that's strong enough to hold building materials together. Now, you might be wondering, wait, are we using a valuable farmland? And that's a great question. But this is a really critical point. We are not talking about using precious topsoil, the kind we absolutely need to grow our food. This process uses subsoil, that layer that's found underneath the topsoil, and it is abundant all across the planet. This means we can build without compromising our ability to eat. So you can see this breakthrough is so much more than just a fascinating lab experiment. It's pointing toward a radical new future for architecture and construction, one where our buildings are sustainable by their very design. What this really represents is a direct, viable alternative to the polluting, high-energy methods we've been relying on for centuries. It's a path to creating the homes we need in a way that works with the Earth, not against it. Which leaves us with this final, really provocative thought. By harnessing the innate chemistry of the Earth, are we on the verge of a future where our buildings are less constructed and more grown? It's a powerful idea to think about, that the solution to building a greener world has been waiting right under our feet this entire time.